Hello. In this video, I'm going to explain how you can travel forward in time. So let's take a very simple scenario. Let's say you have a twin, and you and your twin are separated. You stay on Earth, and your twin is taken on a spaceship. He goes on a spaceship that travels really fast. Let's just say it travels at half the speed of light. So, and each you and your twin are given a weird clock, this thing in your hand and on the spaceship. And what that clock does is, well, it has a ball in it, and that ball just moves up and down. That's all that it does. It just keeps going up and down at a constant speed. That's all that it does. So, for you, what that clock is doing, or what it looks like it's doing, is just moving up and down, because you're just here on Earth. You're just hanging out. That's all that it's doing. But to you, what it looks like your twin's clock is doing is this little weird motion. It's kind of doing a Pythagoras motion almost, because as something goes up and down and moves, let's say that way, it's going to look to someone standing still as if it's traveling in that direction or in that pattern. So, since we know that the distance it's going up and down is constant, and we know that the speed that it's going up and down is also constant, then the only thing that's actually changing is the time. That may sound a little bit strange, because you could say, well, we could obviously see that the distance is longer, but this isn't the actual distance that it's taking. It's still going just up and down, but to us it looks like it's taking that route. So since we concluded that the only thing that changes in the speed equals distance over time equation is time, then we can conclude that time on the spaceship seems slower relative to you on Earth, meaning that if you spend a year on Earth and your brother comes back from the spaceship, he could have only spent 10 days, and he won't look older than 10 days, but you will be a full year older.